Look at this ledger. On the left is the traditional way to upgrade a core testing framework at a massive software company like Asana. It was estimated to take at least 5 years and cost roughly $6 million in engineering time. On the right is what actually happened. The entire project was finished in 2 weeks, and it cost about $12,000. To pull off this collapse in time and money, Asana didn't hire a massive new team. They used a single 5-sentence text prompt to deploy 4 AI coding agents. As this diagram shows, a lone human overseer sat at the center, while the agents worked in parallel on identical copies of the codebase. The human engineer's time shifted away from writing original code and toward high-level direction and review. Instead of building the raw architecture, they became the supervisor of a machine workforce that generated every single line. A 5-year timeline collapsing into 14 days represents a structural shock. The financial math that supports massive engineering departments and traditional tech staffing is breaking down in real time. You can see the human consequences of this pressure at the very top of the industry. Right now, a wave of senior engineering leaders, CTOs, vice presidents, and department heads are actively quitting or taking extended career breaks. The burnout stems from an impossible mandate. Founders are demanding their companies instantly transform into AI-native operations, while simultaneously slashing the actual engineering budgets by 20 to 50%. Add to that a broken compensation model. Because venture capital payouts heavily favor investors first, a startup might need a $200 million exit before a regular shareholder sees a single cent. The equity these leaders hold is increasingly worthless. The old tech playbook of building massive teams to hit a massive IPO is broken, leaving a vacuum of experienced leadership at the top of the industry. The pressure on human engineers is directly tied to what AI can now do completely unsupervised. In one session, an AI agent named Claude Code spent roughly 4 hours reverse engineering an undocumented HP printer driver to make it run natively on a Mac, a complex hardware problem HP itself never solved for its users. We are moving past standard chatbots that simply generate text. These agentic swans execute deep end-to-end systems work. They write the tests, run the code, see where it fails, and fix the errors autonomously. This level of autonomy is exactly why OpenAI recently hit the brakes. They voluntarily halted the final reinforcement training stage for their largest planned AI model. During internal testing, their own safety monitors triggered an alarm. The model was approaching a critical, predefined threshold for cybersecurity capabilities. It was getting too good at hacking. When the creators of the technology have to temporarily freeze their biggest project because the AI is learning to breach systems autonomously, the systems have crossed from theoretical tools into active operational threats. As the top-tier models get more capable, the hardware needed to run them is getting drastically cheaper. This network diagram illustrates a breakthrough called ExactMoE. It solves the biggest bottleneck in AI, memory limits on graphics chips. By storing rarely used parts of the model in cheaper system memory, it cuts the required graphics memory by 87%. Efficiency is also rising because newer models activate only a tiny fraction of their internal parts per query. An AI with 30 billion parameters might only use 3 billion of them for a specific question, slashing the active computing cost. Researchers are also learning that agent memory is a calibrated dose that can be tuned. Feeding a weaker model a small, curated amount of context improves its performance by double digits, but overloading it with data just confuses it and wastes compute. Squeezing frontier-grade intelligence into highly efficient, cheap hardware footprints means the power of AI is decentralizing. It is moving away from massive server farms and into the hands of anyone with a modest GPU. Because the hardware is getting cheaper, the intelligence itself is becoming a utility. Free, open-weight models like DeepSeek V4 Pro and Kimi K3 have reached performance parity with the proprietary labs. These models arrive under clean, permissive MIT licenses, granting developers complete, string-free commercial freedom to build products on top of them. This comparison table shows exactly what that does to the market. Proprietary giants are charging around $5 for every million input tokens. Open models on fast infrastructure are undercutting that price by 80%, charging just a single dollar for the same volume of data. The era of the monolithic God model is over. Intelligence is no longer a marriage to one provider, but a commodity ordered from an open menu. Since the models are interchangeable, the money and power are moving up a layer. The new strategic high ground is the router, the automated traffic controller that sits above the AI and decides which model handles your request. Take a look at this routing diagram. An enterprise search company called Glean recently hit $300 million in annual revenue. They did this by building a central router that instantly evaluates an incoming task, checks the menu of available models, and deflects the request to the cheapest, most efficient node for the job. Research systems like RoboPhD are pushing this even further. They use evolutionary algorithms to automatically assemble custom teams of AI agents, instantly snapping connections to cheaper models to hit exact budget targets without losing an ounce of accuracy. This shift turns the human engineer into a commander of swarms, rather than a builder of individual components. The role has permanently moved from the workbench to the bridge. Absolute power in the tech industry no longer belongs to those who build the brains, but to those who build the switchboards.